Welcome to the final week of Data Engineering for AI course. In this week, we are going to take a look at some of the data engineering tools that are prevalent in the industry. But before we get started, it's important to understand some of the digital transformation terminologies. So in this module, we are going to get introduced to Agile methodology. How is it different from what was used traditionally, the waterfall technique? We are also going to get familiarized with another term called the DevSecOps. So this DevSecOps also is under Agile, but it's it's how the development and operation work together with security thrown in. So it's more of a mindset as well. So we are going to talk about the DevSecOps mindset. And then we are going to talk about the automated deployment pipelines, which is essentially the continuous integration, continuous deployment pipelines, how it's becoming more and more relevant in organizations. And finally, version control. So till now we have talked about version control of application. So in this module, we are going to talk about how version control can be extended to infrastructure, data, your data models, etc. So let's get started. Agile is being more and more used in a lot of organizations. So let's try and understand and break down Agile. So Agile essentially is a mindset or a methodology rather than a set of steps. So it started with Agile Manifesto. So go ahead and Google Agile Manifesto and read it. It's a very, very small document. It talks about the fundamental crux of what Agile is. So Agile is a methodology that is aimed to accelerate outcomes. So equal to speed of outcomes. So it has nothing to do with how fast you are able to deliver stuff, right? So when we say outcomes, it's usually very customer centric. So outcomes are based on typical flow of feature, for example. So let's get to understand Agile from a quote from Atlassian. So Atlassian has created a number of tools built around this Agile mindset. So if you might have used some of their tools, which is Jira or the associated tools as well, right? So what Atlassian says is Agile is an iterative approach, right? So it's essentially doing things multiple times. So it's an iterative approach to project management and software development. So why this iterative approach? Because it helps team to deliver value to their customer faster, right? So that is the speed of outcomes. The speed is on identifying what is the key value to customer rather than just deliver feature after feature. So instead of betting everything on a big bang launch, which was the traditional way of waterfall model, an agile team delivers work in small but consumable increments, right? So the requirements, plans and results are evaluated continuously, so the team has a natural mechanism for responding to change quickly. So this becomes very, very important in a dynamic space where most of the software development is happening, right? So the goal of an agile project is essentially deliver a continuous stream of high value to the user or your customer. Okay. So the difference here between user and customer is because sometimes organizations tend to call only external paying customers as customers, but Agile works for even internal projects where their own employees are users, right? So the high value is with regard to the users of the software. So that could be external customers or it could be internal users, right? One of the common myths about Agile is getting done deliverables done faster. So that is that could be one of the potential outcome, but it does not mean you do more work in less time. Okay, so the whole idea is not to reduce your timeline delivery, but it's a way of rethinking how you can execute a project so that it can be done in an iterative way. So in the next slide, we'll talk about how it differs from the traditional waterfall technique. So in this slide, we'll compare visually the waterfall way of project management or software development and the agile way of project management and development. So a typical waterfall model starts by discovering what is the problem, which is the business requirements, designing it, right, doing the technical specifications, developing it and testing it. Right, so this is aimed towards a big launch. So project planned in its entirety, so the whole project is planned upfront, so a lot of thinking happens before starting. Right, so a lot of assumptions are made at the starting point. So the if you have worked on such a model, which I have when I started off my career, this is the way in which we worked. So we did a lot of business requirements. We asked a lot of questions to the best of our knowledge, right? But a lot of assumptions were made as well, because the customers have not seen anything. It's a new product that's being developed, so it's very difficult for them to also answer a lot of our questions. So we made assumptions, right? So in a typical waterfall model, you make a lot of assumptions. So what is the biggest drawback of this waterfall model is it can be painful and messy to change direction. So let's say at the time of development, you see that there is a big problem, right? You need to sort of go back and redo, sort of get your requirements right again and do your design and development, right? And then just God forbid that you find something, you build something after. So this whole thing, also think of it as time, right? So there is time that is going by here, right? So whenever you discover something, so which is usually at the test time, then you have to go back to your drawing board and redo this, which makes it even more difficult, because you have invested quite a lot of time doing discovery and design based on the business requirement, right? So no fault, but organizations are also very dynamic and they keep changing, right? So that is why Agile came about. So Agile is essentially trying to do the same thing, but in a more iterative manner. So let's look at this visual for a minute, right? So the same set of action of discover, design, develop and test happens, but it's happening in shorter periods of time and in overall sprints, right? So a typical cycle is called a sprint. So here also think of the time it takes, right? So of course the whole is to not execute the entire project as discover, design, test at this point. So a lot of people tend to think, hey, Agile means you're going to deliver something faster. But the first sprint is going to just give you a very high level version of what is going to happen, and then we will go ahead and add in all the frills, right, in a particular development. So what happens is that same time tends to get used in a more optimized way. So if something was found in the first sprint, then it can be corrected very clearly, right, in the subsequent sprints. So this is as we saw in the last slide, it's an iterative project delivery technique. So acknowledgement of an unknown final state, right? So Agile sort of assumes that you don't know what is the final result that you want, but we are going to build that in an iterative way. Assumptions are tested. So every test, there is something you're assuming and you test it. So there are multiple cycles. So that gives us what the new term in the industry, which is experimentation, right? So you make an assumption, but you have the time to test an assumption as well. Whereas in a waterfall model, you make most of your assumptions in your earlier part of your discovery and design, and then stick through for the rest of it, right? So future plans created as learning is gained, right? if something new, something went in your first sprint, then you can sort of correct it when you do your second sprint, right? So the whole idea, of course, there are a few things that needs to be taken care in an agile process. Typically a sprint has to make sure that you have at least one whole flow of a feature, right, end to end, so that you will be able to, it's not just hey, in sprint 1 you do 1-2 feature, sprint 2 3-4 feature. That's not how it works, although some organizations I know also tend to organize it that way. But the whole idea is, how can you create a whole flow in your first sprint so that you can see what's happening, right? But then sort of add on the frills. So one way to think about agile is, see, if you want to go from place A to place B, you used to go via your walk, right? So that's your first way. Then came about bicycles, right? And then came about probably these scooters, right? Pardon my drawing. And then came about car, right? So car did not start off as saying that hey, you have your tire, etc., but it's come about as multiple mobility devices to get to a car, right? So that is how, so you still want to get from place A to place B at every step, ideally, and then you're adding features, right? You're adding hey, this can only take one person, and then probably somewhere as a bike here, and then comes a need for a car. So very close to the agile methodology is something called a DevSecOps mindset. So this terminology has also evolved over the time. So previously it used to be DevOps, now it's DevSecOps. So let's kind of understand what DevSecOps is, right? So DevSecOps is made up of three separate words: development, right? So your essential agile planning happens, right? You discover, do your design, develop and test, right? And then what happens in a typical software application is you also have to deploy your application, right? So that is typically taken care of the operations team, right? So the operation team is in charge of the release of the tested code, then they do the deployment, operate and monitor. So along the way, what happened is, because of agile, the development on operations started going together, because you need to know what are the problems with deploying your solution during the development time, so that, because you are essentially creating this whole circle, right, at one go. So it's important to put dev and development and operations together. So that it came about as DevOps. Then it was also important to understand that security needs to be part of all the steps. So that's the reason of DevSecOps, where Sec stands for security, right? So DevSecOps is development plus security plus operations. So this is the key, why this mindset, right? Because if you look at developers, they are excited about creating new features. They think change is good, changing your code base, right? They are all for change. So the mindset of a developer is looking at the future, creating new things, right? Whereas the mind of a security or operation person is stability of the application. So if something is already running, don't disturb it, right? So they come with a mindset that change is bad. So it's important to put these two mindsets together for making sure you're running the whole system well, right? So that's the whole idea of your DevSecOps. So it is a methodology that reduces software delivery times, improves application quality, right? Mitigates against security issues and enhances the productivity of the development, security and IT operations team. So it facilitates the continuous delivery of values to end user. So how is Agile different from DevSecOps? Technically, they are not different, but it's all, some organizations Agile is the methodology, whereas DevSecOps is how it's implemented, right? So there are, when we talk about tools, they always call them as DevSecOps tools, right? So are your development and security development, security and operations team merged? So earlier, at least when I started working as a software engineer, we had a development team. There is a QA team, quality assurance team, right? They were testers essentially. So most organization you would have seen there were development testers, and then your admin, sysadmin, system admin, who were in charge of deploying it, right? So that is what happened. But then now there is a single role software engineer who's expected to do development, operations, and your security. You develop, test, and you make sure that so in the earlier days, developer just did unit testing, didn't do integration testing. The integration testing was at the quality assurance. But then now today, with a lot of core version control, etc., the software engineer is the title, right? They are in charge of doing your development, operations, and the security. So DevSecOps emphasizes a shift in mindset. It encourages increased collaboration between development, security, and operations, because they tend to come from places of different motivations. So it brings together agile practices, automation, and more to promote efficiency and faster innovation. All right, so having seen the agile methodology and how it differentiates from the waterfall model and the DevSecOps, so now let's dig deep into how it all gets implemented really. Okay, so the typical way, as you can see, is the SDLC. SDLC essentially stands for the software development life cycle. So in a waterfall model, there is just one cycle, whereas in an agile model, there are like iterative steps, right? So this, of course, is a slightly more elaborate cycle than what you saw in the last screen. So here you have planning, analysis, design, implementation, testing, integration, and maintenance, right? So these are all typical steps in it. Okay, so testing is a very, very important part of your SDLC. So in the testing phase is where the different components, so there are different levels of testing, of course. If you are a software developer, you would understand you do unit testing for every piece of code that you write all by yourself. But there is also integration testing, where different components of the projects are integrated together into a dedicated testing environment, and to ensure that they work seamlessly in an integrated fashion, right? So as the development and operations sort of go together, what happens is the way in which traditionally testing used to be done has to be relooked at a little bit, and through that came this new methodology called the test driven development, TDD. Right, so this is a software development process where you write your test case first. So even in your regular this thing, development happens, test case gets written simultaneously. But in a test driven development, what happens is test case is written, because at the end of the day, we want a specific use case to be churned out in a particular sprint, right? So the test case is written, and the code is written in order to fulfill the test case, right? So you write the test case before writing the production code in order to make that test pass, right? So it's a slightly different way of thinking about it. So it's just a reorganization, because currently you're not only interested in the development of a feature, but you are also going to look at how is the feature going to end up looking from a customer's point of view, right? So you begin with failing tests. So this is an iterative process, because what happens is when you start writing your production code, so you have a test case. So you start by failing the test case, right? So that's your red zone, right? The test case fails. So you write a code, right, which will unfail or make the test case work. So this sort of keeps going to make sure that all the tests pass, right, in order to make the test pass. So this is a agile way of thinking, where testing is put together with development really, and not for all the development to wait, because the develop and the operation sort of has to are moving closer together in the SDLC process. All right, so next we will see how this essentially starts a new paradigm called the continuous integration and delivery, right? Because now you're not doing full development and then doing integration testing, but you need to keep doing development and testing and development and testing. So the way the system needs to be designed is going to be very different, right? So let's take a look at that. So having understood the SDLC process and the motivation for test driven development, so now we are ready to understand a very, very important methodology of the Agile process, which is CI/CD. So CI essentially refers to continuous integration. So it is the process of automating the testing and building of code every time a team member commits a change to the version of the code. So think of it, you're building a large software. There are multiple people who are essentially working on different features. So even let's think of a simple software like Swiggy, for example, which is delivery app, right? Food delivery app. So you have people who are working on the front end, people who are looking at the payment side, people who are trying to bring new vendors on board. There are people who are essentially looking at how the delivery system is going to work, right? How the dispatch of drivers is going to happen. So that these very, very, very different components, and as we have seen, the architecture for such a intensive application is mostly microservices based. So everybody is working on enhancing their particular set of modules. So every time that commits happen, there needs to be a process, because no longer you can do development and then do your testing, like, oh, at the end of the week you integrate all the codes. That's how traditionally it used to happen, at least when I started doing software development. So at the end of every week we put in all the changes that happen into the test environment, and then the binary goes. It could be 1 week, it could be 2 weeks, it could be a month. So it depends on the plan really, right? But now the mindset has changed to continuous integration. So it's important to do some automated testing every time, right? So the CI followed by CD, which is continuous deployment or continuous delivery, expands upon the continuous integration by automatically deploying all code changes to a testing or a staging environment, right? So that's why there is a slight, so you'll see some people call D as delivery, some call it continuous deployment. But the whole idea is, hey, once your code, you start writing test cases in code, so that you can every time a change is made, there is automated testing that happens, and it gets deployed into a staging environment for the integration testing to happen essentially, right? So CI/CD is cited as a very important pillar as the DevOps workflow. Right, so because in order to reap the benefits of the CI/CD, companies needs to build an effective pipeline. So this is the very important. So there should be a infrastructure underlaying this. So these are all terminologies which are in the textbook unless it is actually practiced, right? So a lot of organizations are probably doing fully automated CI/CD. Some people are doing semi-automated CI/CD. So depending on the maturity of an organization. But if an organization is really fast-paced, right, where they are churning out features every week, they really need to set up the infrastructure, a very effective pipeline to automate their build, integration and testing process, right? So we'll next take a look at how the pieces sort of fit together in the CI/CD deploy pipeline, as it's called. So this image sort of gives you the how the pieces sort of fit together, right? So the building process is where development happens, right? So how build happens? So there are programmers coding on their machine. right? So then they check in the code, right? So that's the build that happens. And then once any change is made to the code base, it needs to be tested, right? So this process needs to be automated because the number of commits that happen to the code is also going to increase. So every day there is a commit, or every 2 days there is a commit, etc., right, to fix all the bugs. So this is now an automated process, right? From build, it triggers the test, and then you have acceptance testing, which is a bunch of test scripts that get run, and then you auto deploy to the staging. So this is your continuous delivery system. So it stops at deploying to the staging. So this is your continuous integration where you build and test, and your delivery is, hey, a bunch of use cases are tested, and then it's deployed into staging. And then of course you keep the production environment a little bit isolated because the exact code that goes into production, which is essentially what the it is essentially what your customer actually sees, right? That's kept in a manual fashion, because only if this is all ticked off, then it's manually deployed. Of course, there is continuous deployment as well, where this process is also, there is a bunch of test cases that run, which is slightly different from the kind of test cases that run here. So there will be a lot more test cases that run here before it's deployed to production as well. So the continuous integration, to reiterate, is the process of building and testing code. So continuous delivery involves the acceptance testing and deployment to staging, right? So all these steps are automated in a CI/CD pipeline. The final steps require a manual approval of changes, in this case, right, before pushing to production. So this is manageable for a small company or a startup, right, typically, but quickly becomes, if you are making a lot of changes every day, then at the end of the day, you want it reflected on your production system as well. So that is why the continuous deployment happens. The final push to the production step is also automated, right? So this is where it's important to understand the importance of testing our code base, right? You want to, so there are test scripts written to automate the testing as well. So continuous integration includes both your unit testing, which is testing of your individual component, and your integration test. Acceptance tests typically use some sort of framework like Selenium test with the business user requirements, so that the acceptance testing, so typically in the earlier years, this used to be called a UAT, user acceptance testing, right? So there are today web-based tests that can be done to quickly, so that not every time we have the luxury to have somebody go into the website and do it, right? So now we can automate even a machine to open up a browser, go and look at a functionality, and this is this what we wanted to do. All right, so this is a very important part of your DevOps workflow, and the most popular tool that is currently used for CI/CD is Jerkins, right? So this is being used in order to deploy this. So having understood Agile, the DevSecOps, and the need for continuous integration and continuous testing, so now let us start looking at your application, right? So till now, we have only been talking about version control of your code, which is your application, right? But typically in a full-fledged software system, there are three types of stacks that are there, three types of architecture. So there is an application level architecture, how your application is architected in terms of microservices or monolithic, which is what we have seen earlier. Then you these applications run on infrastructure, right? So your cloud, there is an infrastructure architecture. So is it running on a VM, or are you plugging multiple cloud services, etc.? And then on top, there is also a data model architecture. Under the hood, is it a NoSQL or a SQL database? So what is the architecture there? So now, previously when we talked about stack, there was only an application stack. But today, there are three types of the stack consist of all of these three things. So you need to take care of changes that happens in your application, which is code. Need to take care of changes that happen in the infrastructure, which is your operations side. Need to take care of changes that happen in your data as well, right? So all of this needs to come together. So what essentially that means is no longer it is required only to track changes in your application. You need to track changes in your infrastructure, to track changes in your data as well. So version control needs to be extended to these other architectures as well, right? So that is what we are going to see in the subsequent slides. So in this slide, we are going to get introduced to version control. So version control is essentially, we have taken a look in the Git lesson as well. It is a practice of tracking and managing changes to your software code, typically application code traditionally, right? So your version control are software tools that help software teams manage changes to your source code over time. So Git has become very popular, but Git is not the first version control system ever. Right, so there were I forget some of the earlier tools that we used to do. We had something called the VSS, virtual source safe, something like that, which would essentially do version control. So we had Windows level version control, and then web version control became popular, right? So earlier version control referred to, as I said, only to software application code. With the new technology stack and the three components that we saw, version control is not only restricted to application. So it is important to version control the infrastructure and data models as well, as they are also constantly changing in the cloud world. So let's get introduced to a new terminology that has started existing, which is infrastructure as code. So having talked about version control, so now we are going to get introduced another terminology, which is infrastructure as code, IAC. So we saw how with the evolution of software applications, etc., the need for version control is not limited only to the application layer, but also to the infrastructure and your data layers. So infrastructure as code is about writing code to provision, manage, and deploy these IT infrastructure. So this could be on the cloud, it could be on premises as well, right? So the visual here actually helps you to understand it better. So you have your user or your developer who writes code, which needs to get deployed into an infrastructure, right? So infrastructure also needs to be changed based on the requirement from the user, right? So infrastructure is written as configurable files that are both human and machine consumable, right? So of course, because the humans are the ones who are writing it, it needs to be human readable, and then the machine also needs to understand. So there are a bunch of infrastructure as tools. So Terraform is one such open source tool. There is AWS Cloud Formation as well, right? So now you can sort of see that how the development and operations are now having to sit very close together. Because they are coming together, it is a need to take care of operations at the time of development as well, because previously infrastructure used to come only at the time of deployment really, right? But with more deployments, more frequent deployments happening, they have to come together. So infrastructure also keeps changing. So here is a very quick sample configuration file. So if you look at it, typical configuration, this is to just show that how you can actually write your infrastructure. So you have a web server capacity. You talk about, hey, what is a typical capacity, 1 to 5. So what's the DB allocated capacity, right? So then what's your DB name? So every resource, every infrastructure you use. So it need not be only cloud, it can be for your on-premise system as well. So a sample, so this is to just show you how a typical infrastructure as a code looks like. So now that you are able to configure infrastructure as code, so you can understand, now you can version control them as well, right? So, so here is to just give you an example of a configuration file that automates the configuration and deployment of a web server and database with AWS CloudFormation. So you can see there are a lot of these resources of your DB name, username, password, and what's your web server. We talked about the DevSecOps mindset. We talked a lot about development, which is what we all do day in and day out. And then we have started talking about operations of how they two come together. So there is a very important part of it, which is security, right? So security can also be written as a code. So we are not going to delve deep into it. I have given you a few references which you can refer to if you want to understand a little more. But it's important to address it. Right? So security as code is the methodology of codifying security and policy decision and socializing them with other teams, right? So this is very, very important because security, so now companies are doing security code review to detect security flaws in other person's code, right? So to find the errors in the code that can be exploited if they reach production, right? So this is what typically happens. So security testing and scans are implemented into your CI/CD pipeline to automatically and continuously detect vulnerabilities and security bugs. So if you are able to run test which is functional, so most times when we talk about test, it's a functional test, right? So you are only looking at functionality, but it's also important to understand because now your code is going to sit in an infrastructure, so it's becoming closer together. So security needs to be a very, very important part of this process. And how do you get security at scale? Only by automating security testing and scans, right? So the security impact of each design decision, it is very important to start thinking about it. Think from an attacker's point of view. That's your essentially what is called a threat modeling, right? So the access policy decisions are codified into your source code, allowing everybody across the organization to see exactly who has access to what resources, right? That becomes very relevant. So security behaviors which are instilled in DevOps teams are something called threat modeling typically, which is threat modeling is analyzing the security impact of every design decision that's made in the application level. So thinking of it from an attacker's point of view, how is the application going to, what's the stack that's required for this application, right? Stack, application infrastructure stack. So think, are there vulnerable points, right? Choose design decisions that protect the confidentiality and integrity of your customer data. Then you have, as I was talking about, the security code review. So the security code review is detect security flaws in other person's code, find errors in the code that would be exploited if it reaches production. Then there are other practices like red teaming, which is essentially attack your code with the same veracity that bad people will apply, right? So instead of getting hit by an unknown attacker, do it internally when it reaches production. So uncover flaws using active testing, right? And fix those flaws and push the fixes to production as fast as possible. So there are all of these multiple things sort of coming together, as you can see in an agile system. All of them have to come together, but depending on the organization, I certainly would tell you that not all organizations are at complete automated testing, automated security, because it's a process, right? So they have been in the traditional space. So people, you will see startups which are building products today are already building it in an agile way, because they are creating their infrastructure in the cloud, whereas traditional organizations like your banking, your insurance, your travel industry, etc., they are going through this digital transformation. So having talked about version control of application and infrastructure, I wanted to end by talking a little bit about version control of data. So version control of data includes versioning of your data, versioning of SQL that is used to transform your data, versioning of machine learning. So when you are using advanced machine learning models, right, how do you version? So there are multiple version controls that's really required here, right? So that's where, so first it starts with security of your data, then it comes with version control of your data as well. So there are two kinds of data workflows that we have already seen. You have your ETL process, your extract, transform, and load, and then your ELT process where you extract and load all the raw data and then do your transformation. So in this module, we are also going to talk about DPT, which is a transformation workflow tool that helps to get your work done while producing high quality results. So what that does mean is you are essentially doing version control of this transformation step, the T that is there in your extract, transform, load and transform, right? You have your raw data. There could be multiple transformations that required for multiple business use cases. So how do we track changes of these transforms? So till now we have been doing SQL queries, right? But how do we build data models which can be used across organization? So DPT can be used to modularize and centralize your analytics code while providing your data teams with guardrails, which are typically found in your data engineering process, which is essentially your versioning, rolling back to the earlier versions, etc. So we are going to take a look at DPT, which stands for Data Build Tool. So DPT helps to collaborate on data models. So teams can jointly come up with data models, version them, test and document your queries before safely deploying them on production with monitoring and visibility. So you can see how all the pieces needs to fit together. So there is version control of your application, version control of your infrastructure, version control of your data as well. Right. So of course, version control of data has multiple versionings depending on what is the level of usage of data, right? So first is your data itself, security on that, and then you have your transformations, which is the very first step of your analytical process, right? So DPT plays a very important role, and we will take a deeper look at that in this course. Well, let's summarize what we have learned in this module. So in this module, we got introduced to the agile methodology, and we compared it between compared the waterfall model with the agile model, and what are some of the ways in which they differ. Basically, the iterativeness of the agile methodology. Then we got introduced to the DevSecOps mindset, which is essentially bringing together the development and operation of software development together with the security aspect. So since we didn't go deeper into the security aspect, you can take a look at some of the references I have given at the end of this chapter to understand a little bit more about security as a code. Further, we talked about the automatic deployment pipelines, the continuous integration, continuous deployment, continuous delivery pipelines, which is a very integral part of agile methodology because of the iterativeness in which the product development essentially happens, the software product development. So it is very important to have these automated, else the number of releases are going to be a little more tedious to do the releases. And finally, we talked about the stack of how version control is not only limited to application, but also infrastructure and data. Alright, so in the next module, we will continue to talk about version control of each of these different aspects, which is infrastructure and data. Alright, so please do take a look at the references that are given at the end of this module. Thank you. I will see you in the next one.